So for topic 6, we're going to look at formulas and mathematical models. And first, I want to remind you of a couple of things from previous videos. So formulas are basically special types of equations. And remember from a previous video, equations are mathematical statements that says two algebraic expressions are equal to each other. Okay, so we already know how to determine if we have an expression versus an equation. We also looked at direct translation, which is the process of converting words to math, which is really important when you start talking formulas and mathematical models. So we know how to create expressions and equations from words. We also know how to check to see if a value is a solution to an equation. So all of those things kind of combined are going to be really helpful for topic 6. So let's talk about formulas and then we'll start looking at a couple of examples. So definitions first, a formula is an equation that expresses a relationship between two or more variables. That's really important. Formulas are very real world and they show relationships between at least two, potentially more variables. So you will have more than just the one variable present, okay? The process of finding formulas to describe real world phenomena is called mathematical modeling, okay? It's like its own branch of math. Formulas, together with the meaning assigned to the variables, are called mathematical models. So a lot of times, instead of saying formula, you'll be asked to find a model or a mathematical model and vice versa, okay? So let's go ahead and take all of that information and look at example 7. Okay, so example 7 says use the given model or formula to answer the question. So in this case, it's nice because they've given you the formula. You don't have to create it. You don't have to use direct translation here. It's given to you. You're just going to use that formula to come up with some additional information. Okay. So in this case, it says the model T equals 0.16 N plus 2.83 describes the average movie ticket price T. So the average ticket price is going to be the variable T in years after 1980. So N represents the number of years since 1980. The question we have to find is what could you expect the ticket price to be in 2030? Now, keep in mind, this does not tell us exactly what the ticket price is going to for sure be in 2030. Basically, somebody's collected a ton of data for years and years and years and years, looking at average ticket prices in different years, and then they've come up with this model that best represents ticket prices. Now, we know that ticket prices vary greatly depending on where you're at, economical type situations, what day you go to the movie, like what time of day you go to the movie, matinee versus evening. So this is not going to be an exact science, but given this formula, what could we expect the ticket price to be in 2030? Now, remember, N is the number of years since 1980. Okay, so before we can find the average ticket price to be expected in 2030, we need to figure out what N is. So N is the number of years since 1980. So take whatever year is in question, so 2030, subtract 1980. And when we do that subtraction, we get 50. So we're looking to see what the average ticket price is when N is 50. Okay, so you take T, anywhere you see an N, plug in a 50. So we're kind of doing that evaluating thing. We've done that a couple of times. So we get 0.16 times 50 plus 2.83. Now, this is stuff that we could absolutely do on paper, but at this point in this math class, we let you use your calculators a bit more. So if you have a calculator, go ahead and get that out. I'm going to switch screens quickly. Now, remember, we were checking to see what the ticket price could be expected to be in 2030. That's when N is 50. So the first thing I need to do, because I'm going to follow the order of operations, is I'm going to multiply 0.16 times 50. That gives me 8. And then to that, I want to add 2.83. So we could expect the average ticket price in 2030 to be $10.83. So let's go back to the regular screen. So when we went to the calculator, we found that 0.16 times 50 was 8. To that, we're going to add 2.83. So we would get that the average ticket price in 2030 could be expected to be around $10.83. Again, this isn't an estimation at best, okay? Likely an underestimation because I suspect the ticket price will probably be more than that in 2030. But according to this model, with whatever data they looked at, they would predict that the ticket price in 2030 would be on average $10.83. So this is the average ticket price in 2030. Anytime you have something that's a word problem or has a lot of words in it, some kind of a scenario dealing with formulas or any kind of mathematical model, always explain what your answer is. Even if it's just a couple of words, you could say $10.83 ticket price or $10.83 in 2030, but explain and describe what your answer is. All right, part B. So we have a brand new formula this time. So it says the formula E equals 325 plus 0.055x represents the weekly earnings. So we know what E is. E is weekly earnings for a salesperson who has a base salary of 325. So this 325 means they're going to make 325 no matter what. That's their base salary, but they earn an additional 5.5% of their weekly sales, which would be X. So when you have these formula type problems, pay really close attention to the wording and the description of the variables, and then compare that to the actual model. Okay, so we know E is the weekly earnings, 325 is their base salary. If they make sales, they get to keep 5.5% of that. So that 0.055 is 5.5% just written in decimal form. So to go from a percent to a decimal, you move the decimal to the left twice. Okay, so what we need to do is determine the weekly earnings for a salesperson if their weekly sales, that's X, are $3,600. So we want to find E if this salesperson makes $3,600 in sales. So we're going to take 325, we're going to add 0.055 times X, but remember, X is $3,600. All right, so let's go to the calculator again. And following the order of operations, we would be concerned with what is 0.055 times 3,600. That's called commission. When you earn a percentage of your sales, it's called commission. So the commission for the salesperson is $198. And remember, they had a base salary of $325. So whether they sell a ton of stuff or sell absolutely nothing, they still make $325. So for this salesperson, their weekly earnings would be $523. So let's go back to the worksheet. So we know they're going to make their $325. We were able to calculate their commission, the 5.5% of 3,600, which was $198. And when we combine those two, this particular salesperson had weekly earnings of $523. And there you have it. So what was nice about example 7 is you were given the model. You were given the formula that you needed to use. For example 8, it's going to be a little different. So for example 8, we're going to have to create our own model, okay? So it says a plumber charges an assessment fee of $45. So if this particular plumber comes to your house, whether you hire them or not, you owe them $45 for coming and just checking out your situation. They then charge an additional $22.50 for each hour of labor. So you're going to get charged the $45, and then if you hire them, you're going to get charged an additional $22.50 for each hour that they work. So part A says create a model that represents the total cost C for having the plumber work H hours. So they're telling us what variables they want us to use. So we know C is going to be the total cost to hire this plumber. And we know right out the gate that we're going to have to pay this plumber $45. Okay. In addition to that assessment fee of $45, we're then going to have to charge them $22.50 times every hour that they work. So $22.50 times H tells us the labor, and then the $45 is the assessment fee. So this is the model right here that we could use. And what's cool about this is if we have any given value for C, we could figure out how many hours were worked. And then on the flip side, given any number of hours worked, we could figure out what C is. So let's see what part B asks us. So part B says, if the plumber works 7 hours, what will the customer be charged? Well, we want to know the total cost, okay? So the plumber is going to charge them the $45 no matter what. In addition to that, they're going to get charged $22.50 for all 7 of those hours, not all 7, for each of those 7 hours that were worked. So let's scoot over to the calculator. So we're going to be charged $22.50 for each of the 7 hours, so times 7. So we're going to get charged $157.50 just for labor. And then in addition to that, we're going to get charged $45. So total, we're going to get charged $202.50. So we had 45 as the assessment fee, $157.50 was the labor cost, and total, the customer is going to get charged $202.50 is the customer's cost. Okay. So we've done two things with these formulas and mathematical models. We had situations where we were given a model and we used it to find some estimation or some value. And then we had a separate one, example 8, where we were asked to create the model using direct translation and then use that model to answer some other question. So make sure you can do both.